So the knobology is simply described as the study of the various knobs or buttons or controls on the ultrasound machine. Knobology can also be described as the equipment controls. Simply put, what is knobology? We know that anytime we see the word logy, it means that it's the study of something. Yes, but in this case, we're talking about studying of the knobs. So simple description is just to say that knobology is knowing the knobs on your ultrasound machine. Knowing the knobs. And what are our learning objectives? At the end of this session, you should have familiarized yourself with the commonly used knobs of the ultrasound machine. 2, be able to know the functions of all the knobs. So you see a machine, an ultrasound machine, there are different buttons on it. Each of them has a function. So at least at the end of this program or lecture or this training session, we want to know the basic functions of the basic knobs that we use. And then you're able to probably familiarize yourself with these knobs for image optimization. The whole aim of, as you scan, one of the things you want to achieve is to have an optimal image. So having an optimal image optimization is one of the aims you want to achieve as you scan and as you learn to scan. And one way of doing that is being able to properly use these knobs to be able to achieve image optimization, to be able to know which knobs are important at each point to use so that you can ensure optimal image, is get a proper image or picture of the structures that you are studying by using the ultrasound machine. Now, first things first, according to Stephen Covey, first thing first, you need to get, if you have a system or you're going to use a system, an ultrasound system, you need to get an application specialist or a system specialist or someone who will help you to install the machine, especially if it's a new machine. You just have to do that. If not, just like getting a new car, or any new machine at that, you need to know how to use it. If not, you may even end up damaging it. So there's no cutting of corners here. If it's a new machine, get an application specialist who sells the machine or who is from that company to help you make sure that the machine is properly installed. All machines come with a manual. Get the manual and read it. Read it cover to cover as if you want to go for an exam. Study it and keep it near you, even as in your practice, so that from time to time you can always go back to it, refer to it, and keep reading it so that you know your machine. If you read it and understand very well, then you will know your machine very well. You use the machine very well. The machine will respond to you and provide the optimal image you want. And also, there's also hope that there's also a higher chance that you will not damage your machine because of ignorance. So adjusting the knobs as you scan is very, very important. So this is one of the things you will learn as you improve in your scanning, that one hand is on the probe scanning, while the other hand is just effortlessly touching the other, using the probes and applying them without even looking at the initial time when you start. Of course, you'll be looking at them, but after a while, you'll find out that you can actually use all these knobs effortlessly and to get your optimal image. And you have to, one of the things you will learn is that you have to adjust your knobs as you scan. It's abnormal to start scanning from the beginning of your scanning session. You're scanning a patient from the beginning to the end. You did not adjust any of the knobs. No, it's not. It's abnormal. It's not normal standard practice. As you scan, you find yourself adjusting the knobs, adjusting to suit you, to be able to be able to obtain the optimal image. So getting yourself very familiar with these knobs, understanding these knobs is very, very important, especially if you're not the only one using a scanning machine, ultrasound machine. For example, you may be in a department where different people are using the same machine. Somebody has scanned the patient before you come, and the machine is still on and on the settings that the person used. You cannot just come and start scanning using the same settings from the beginning to the end of your own scanning session without adjusting the knobs. No, you adjust the knobs and to suit you as you scan. So as again, I will keep stressing it that the whole aim of Knobology is image optimization. We want to ensure that we get proper images, optimal images. I'm sure we're all familiar with this picture. This is how most ultrasound machines are when you see them. So this is how you see the knobs or the controls or the buttons. Okay. First of all, before you start, you have to put on the machine, but the machine has to be connected to electrical source. I'm sure yesterday during the lecture on physics, Dr. Ikubor spoke to us about the fact that the electrical energy has to get into the transducer, excite the piezoelectric crystals inside. So if you don't put on your machine, if it's not on, then then you cannot even start to scan. Then the next thing you want to do is to look for the probe selection. There's a knob called the probe selector or selection. You select the probe based on the examination you want to do. So either you are selecting a high frequency probe or low frequency probe, depending on the examination. And for the purpose of our study, we are doing obstetrics ultrasound. We'll select the low frequency probe or transducer. Most of the machines also have a knob known as the preset, where you have to select it before you start. So you can click on it and then you select the exam you want to do, carry out. So these are all the knobs. We're going to take them one after the other, but I'm sure we're all familiar with this. So when you see a machine, the first thing you do, just take a few minutes to just study it and look at where all the knobs are, so that as you are scanning, you begin to use them effortlessly and you get yourself familiar with them. Again, with the whole aim of having what? Image optimization, optimal images. So again, these are all the knobs I mentioned before that we have just seen on that previous picture. So the power on and off knob turns the power supply of the ultrasound machine on or off. And when you're also done with scanning, they use the same knob to switch off the machine after use. This is very important to always switch off your machine when not in use, so that the machine is not damaged, especially in areas where we have fluctuation of power. Now, menu or the preset, some machines have it have this knob as menu, some have it as preset. So depending on your machine, again, that's why it's very important to study your machine very well, study the manual. In this knob or button helps you to able to document do your documentation before you start, such as the patient ID, patient name, patient ID, okay, very important. And some machines, most machines, if you don't select and document all these patient's name and ID, and you start another patient, all the measurements you have acquired for the previous patient will still be saved for this new one. So it's always good to start first by doing the first thing, documentation, the patient's name, and start the exam for that patient, so that the previous examination, previous recordings, previous measurements do not, the machine does not save them for this your new or current patient. So then in this preset or menu, you also select your examination. So you see the drop box will show up many different examinations. For us, we just click on obstetrics. Others will be gynae, abdomen, urology, etc. Then you select the probe. Okay, you select the probe to use. All this is most of them too is also on the machine. Especially if you have a machine that different people are using. Like in my department, the radiology department, we have the ultrasound machine being used for the examination of different parts of the body. So for each examination, you have to select the desired probe for that examination. Again, that the transducer, there's a knob for this transducer. If you click on it, it will activate the particular transducer you want to use. If it's only ultrasound you are doing, you will not have issues with, you will not need to do all that every time you are doing an examination. But knowing your transducer choice knob to select is very important if the machine is a multi-purpose ultrasound machine in a very busy department. After selecting the probe, then you select your examination. You are now ready to scan. Now, this is a probe connector. Again, most times, it's already connected to the machine. But if you have to do different examinations, then you have to disconnect one probe and connect another one. And this probe connector, which you are seeing in the screen, helps you to do this. Some of these newer machines, you don't even need, some of these newer machines, some of them are just, all you need to do is just to click on a knob, and that particular probe is already activated. But sometimes you may have to actually physically connect, remove a probe and add another one, and this connector helps you to connect this probe to the machine. So this is a probe connector. Now, let us now go back. Let's start to look at the basic knobs that you will use for scanning. One of them is the gain button or knob. Gain has to do with brightness of the image. This is a knob that if you increase it, then the image will be very bright, very white. If you reduce it, it will just become very dark or very black. So as you start to scan, just learn to play around with all these knobs so as you get familiar and used to it. So you can increase the image, the brightness of the image by adjusting the gain. You don't want your image to be too bright, and you don't want it to be too dark. If it's too bright or too dark, you may miss some very important details on that image. So just using the brightness that is just right is very important. And it comes with practice. As you practice, you get used to it. You know that, oh, if I increase this brightness, then if I increase it, it will be too bright. If I reduce it, it will be too dark. So this is just right. So the beauty of it is that it can be adjusted. That's why the knob there. You can increase it, you can reduce it. I know that most people will just want to make it very high, then later will reduce it to the brightness that they are comfortable with. Again, it shouldn't be too high, it shouldn't be too low. If it's too high, it will obscure many details. If it's too low, it will be so dark you will not see anything. So what does the gain button do? It helps to amplify the returning echoes. Yesterday you saw that the ultrasound is all about sound energy, echoes. So the echoes that are coming back to your probe that will now be displayed as that will now display on the screen monitor that you see. This button helps to just amplify it, to make it bright enough for you to appreciate. Now, this is an example of an image, a sonogram, that is the gain is too high, so it's overgained. So everywhere is so bright, you can hardly appreciate any detail here. Okay, this is actually supposed to be the kidney, but you cannot even appreciate. Everywhere is so bright because the gain is high. So we say that this image is overgained. Now this image is so low, it's too dark because the gain is low. And when you're on the ultrasound machine, as you are increasing the gain and reducing the gain, you will actually see that there's a numerical change in the value of the gain. The numerical value is also displayed on the screen. So when you are increasing it, you will actually see that the value is increasing. And when you are reducing it, you see it is reducing. Always look on the side of your monitor, and you will see that the value is either increasing or reducing. So this is too dark. You don't want it to be too dark. So this is undergained. So you just want an image that is the gain that is just right, just correct. So another knob is the TGC, the time gain compensation. In some machines, you see it like this. You see some knobs that are arranged in a vertical fashion, like this. This is the TGC, the time gain compensation. And for each of these, you can actually use it to adjust the brightness of a structure at a particular depth. So this is the use of the time gain compensation. So the knobs are arranged in a vertical fashion, and each of them and of this can adjust the amplification of the sound, so the brightness of the sound or the echoes at a particular depth. Okay, so this will adjust the brightness of structures that are superficial, and as you go deep, these other ones will adjust it. So it's as if at a particular, as if the body is in sections. So at each section, each of these sliders or knobs can be used to adjust the depth at the brightness at a particular depth. They are usually like up to 10, you know. The difference on machines will be like this one is just like 6, some can be up to between 6 and 10. So each of them, you can adjust it to give you, to selectively get the brightness at a particular depth. So when you're examining an area, you can use this time gain compensation to adjust the brightness to that area, so that the brightness of that area of interest is what you can get the brightness of what you want. So it's not as if you are not going to, it's not the whole area of study that you're interested in. It's a specific area. So you just adjust that area, but you just adjust the brightness by selectively touching this particular knob. Some machines, this time gain compensation is known as near gain or far gain control. So depending on the machine, but all of them have the same function. Oh, sorry, I've lost it. Sorry. Sorry. No more seeing my. Sorry, I'm not seeing my. Sorry, I'm not seeing my. Let me share it. Let me do the sharing again.
Okay, ma'am. Yes.
Can you see my screen now? Okay.
Yes, ma'am. We can see your screen now.
Okay, thank you.
Yes, ma'am. We can no longer see the screen, ma. Can no longer see your slides.
Yeah, I'm also not seeing it again. Okay, I think it's loading now.
All right.
So this is the time gain compensation I was talking about. So each of these sliders represent different depths of the area of study. So this area represents the superficial area, like this. This other one will be it will not be the nest, and these other lower ones will represent structures that are lower down. So if you move your slider this way, then this area will be so dark because you have reduced the gain. So if your area of interest is for example, is in this area, which is in this fetus now, this is around the fetal trunk. So, and my area, this is my area of interest, then I will now adjust the corresponding time gain compensation knob, which is around here. So this is the one I will adjust so that the brightness of this area of my interest will be optimal for me to see the structures I want to see. So I will not adjust all these ones, these first three or these last three. It's this area of interest that corresponds to this slider that I will now adjust. So we can now see that this area is this side is too dark. Going down, this depth is so white, so bright, because of if you do that, that means you have adjusted this TGC knob that corresponds to the lower part here. So each of these knobs corresponds to different depths on the area of study. And you can use it to adjust the brightness of a specific area. So the ideal thing is to make sure that the brightness is uniform all through. But when you want to look at study a particular area, then you now reduce or increase the TGC that corresponds to that depth. So this is just putting all that we've been talking about since. Okay, so this is the near gain. It's too dark. This is uniform all through. While this side, the far end, towards the deeper down, you can see that it's so white because the gain here is excessive. So the whole idea is to ensure that you use this knob when you really want to look at a particular depth, and make sure that everything is uniform. So you adjust the depth, the gain, or to suit all areas of the interest that you are studying. In that way, you will be able to have uniform gain. Most times, I notice that the machine may just be set in a particular this TGC is already set already. Most people don't really bother to to adjust it, but you find out that as you begin to scan more, you will use it. You're able to adjust each them depending as you scan, depending on the area you want to look at. You can actually adjust these buttons. The next button, apart from gain, we'll talk about gain, and we said gain is brightness. The next one is the depth button. The depth button it helps you to depth button or the depth knob allows you to adjust, make adjustment of the depth of the field of your view. So you can actually change it, also increase it or reduce it. In that way, it will adjust the depth. So you see the structures that you are viewing can be adjusted. It can make it look as if it's getting bigger or it's getting small, it's reduced in size. All is what this button does for us. So it can help you to determine how deep you want the ultrasound wave to penetrate the area of study. It helps you to adjust how deep you want the ultrasound to get into the body. So this knob helps you to able to even to magnify structures. So you choose your depth. So as you start to scan, you can actually increase the depth, or you can then, as you go along, you then reduce the depth. And as you do that again, as I said earlier, if you look at the screen, the monitor, you will see that you are either increasing or reducing the depth. And as we scan, usually when we start to scan, you will find out that this depth, this depth knob is, you will adjust it as you scan. The depth that you use to start is not what you will use till the end. So you just like the gain knob, you keep adjusting and reducing, just depending on whether you want the structure to appear shallow or to appear deep. So if you want the structure to appear shallow, then you have to reduce or decrease the depth. And if you want it to appear deeper, then you have to increase the depth. So this is what you have to repeat all these movements as you scan, depending on the depth that you really want. For example, if you increase the depth, then the structure will get smaller, so small. Then you find out that you have a lot of dead space, and you don't want that. If you decrease the depth, then the structure will get so deep, so large that it's as if the structure is occupying the whole screen. And then you find out that, oh, you may not even see some other structures because the image has covered the whole screen. So adjusting the depth to ensure that the structure of interest is occupying 75% of the screen or 3/4 of the screen, this knob is what helps you to do that. And as I said, if you look at the screen, you will see the markers, the depth markers. They are usually on the side of the screen of your monitor. So you will see that you are increasing, you will see it increasing and decreasing. Initially, you will just find out that you're just moving it, but you will see on the numerical value, you will see on the screen. So, and with time, you find out that with this depth markers, you can actually also able to appreciate the distance of structures from the skin, from the surface. So you're able to say, oh, this structure is about 4 centimeters or millimeters from the skin. Because you see, you can measure distances from the skin. So these depth markers, will help you to appreciate all that. And again, yes, as I said earlier, is this knob that will help you to fit your image or your area of interest, the structure you are imaging, to fit the screen properly. You don't want the image to be too big or too small. For example, if you are imaging the femur, you don't want it to be so small. You want it to occupy like 3/4 of the screen. So it is this depth button that will help you. So all you need to do is increase the depth. It will allow you to allow you to see deeper structures very well. So initially, we said that the best thing is to start with a very high depth, so that you're able to look at all the see all the structures in one view, what we call the panoramic view, to see all the structures at one. Then as you go along, you can now begin to decrease your depth. So this depth button, gain button, these are very common. These are buttons that you will commonly use as you scan. Now this is an image of the fetal skull. With the patient, you want to do a fetal head biometry, and this is a fetal skull. And then what is the problem here? The depth is too much. The structure of interest is so small because the depth is too much, and look at so much space is wasting. So this depth is too much. So you now have to adjust it by what? Reducing it. Okay. See look at this again. The structure of interest here is the theta femur. Look at where it is. It's high up. Why? Because of the depth. Again, the depth is too much. You need to reduce this depth so that this structure will be just cover, will be within 3/4 of the screen of the image. Okay, now look at this now. You find out that, look at the space posterior to this theta head is not so much because the depth is right. So adjusting your depth is very, very helpful. This is the theta femur occupying like 3/4 of the screen because the depth is right. It's not too high, it's not too deep, it's not too shallow. Okay. So when the depth is too little or it's too shallow or it's too low, the same thing, you will see that all the structure has occupied the whole screen and you cannot even see, there's no space for anything posterior to the structure of interest. And this is very dangerous because this is not too right. I mean, because if there are artifacts such as posterior acoustic enhancement, posterior acoustic shadowing that we see in calcifications, or posterior acoustic enhancements that we see in cysts, we will miss it because of there's no space. The depth is too little. So this depth has to be increased. Now, another button that I want to quickly talk about is the zoom button. Zoom button or the knob, it helps you to take a portion of the screen and then you can now magnify it. Just maybe an area that you are interested in, you click on it, and then that particular area can now be magnified. It will now be, it will blow out, it will be big enough or large enough. And this, you can do this as you are scanning. And if a structure is superficial and you want to magnify it, you can combine both the depth and the zoom button together, and it will help you to get the structure to fill the screen as you want, so that you can really see all the details properly. So if a structure is deep, okay, it's very, very important that you use the zoom. So the zoom and the depth button, as you scan, you find out that you use them together to be able to magnify your image and see detail and see structures in detail. Another knob that we commonly use too is the focus. You use the focus to help you to pay attention to a particular area of your area of study. So this knob allows you focus the ultrasound beam to the area of interest. You can actually manually adjust this as you scan so that you adjust it to the area that you want. So you see some machines, you just see the button for focus, and then you can adjust it. You just see it moving, and you move the knob, or you move the knob, and you see the marker moving. Then the area of interest, then where you really want to study, then you leave it there. Then that area you're able to see more. So this knob helps you to just as the English words, helps you to focus on an area. So you can focus the ultrasound beam to that area of your interest. And the whole of all this is to ensure that you get an optimal image, or you achieve image optimization. Freeze button. This is one of the buttons that when we start scanning newly, we love. It's our friend, because immediately we just see an image of, area of interest or optimal plane. When we are worried that we don't want to lose it, and the next thing, your hand just quickly goes and you freeze. But as you become more conversant with scanning, you are not so worried, because you know that if you have learned the principle of scanning, even if you lose an image, you can always get it again. So this freeze button helps one to be able to capture still images. you're able to display an image that you have seen. You can capture the image on the screen. So image on the screen. So when you press the freeze button on the screen, then you can now take your measurements, you can print, you can also store your images. Okay, so as you scan, you find out that as I said, as you scan, your hand is on the probe, you are scanning, the other hand is using all the other knobs, the gain, the depth, the freeze. And I know that the one that people, most people, when they start scanning, they want to make sure that their hand is so close to this freeze button. In fact, I say most times they want it to be just a striking distance, so that the minute they see, they will just freeze, boom. But not to worry, as we get more proficient and more, as we improve, we will not be scared, we will not be too worried about freezing at every minute. Again, to keep your machine, it's good to freeze the machine when you are not scanning. Sine loop, this knob, most modern machines have a sine loop or a playback function that can allow you to scroll back, and then you can now go through all the previous or several previous scan frame, previous images, frame by frame. It's like as if you are playing like a cinema screen. You can just look at all the images, scroll back, and you are seeing them frame by frame. So this sine loop is for new machines is there. So you can review the images, you can look at how you got them, and then you can actually study them. Now, what you need to, as you use the sine loop, you need your trackball to be able to scroll backwards, to be able to see all the images using the sine loop. So with sine loop, you can also retrieve important images, especially for very fast-moving structures. Okay, you can use it to, you can go back, scroll back, and look at them. So there's really, you can, some people just use it to say, oh, no, when we were scanning that time, we saw some important acceptable image. Let's go back, let's scroll. That is hunting. No, that is not really the aim of that. But of course, you can actually scroll back and retrieve some important images that the machine has stored for you frame by frame. The annotation key is another knob that you can use to take pictures, you can use to label, especially when you need to share your images. So you can share them, you can save your images, and the annotation key is what you can use to label or use for typing. The calipers, very important as we scan, usually as we do obstetric scanning, obstetric scans, we need, the calipers is another very important knob or button that we will use because it's what helps us to take measurements. It enables us to take accurate measurements. So the calipers are available to measure linear distances. For example, when you are measuring the femur length, you can actually, you can use, you also have other ellipsoid, you can have the ellipsoid function of the caliper, so able to take measurements of circumferences, especially when you want to take the head circumference, abdominal circumference. So these calipers can help you to take all those measurements. So the aim of calipers is able to enable us to take measurements. And so depending on which measurement you want to take, you click on it, and then you can now measure. You can take your measurements very well. For example, if you want to take a linear measurement, for example, you want to do femur length. So you can click on the caliper, then you see a small icon or cursor just coming up. You use your trackball to move it to one end of the femur, then you set it, you click set, so that stabilizes it or that puts it in place. Then you click on next, and then it will move the other leg or the other arm of the caliper to the other end of the femur length. the end of the femur, and then you can now click set, and automatically the next the measurement will display on the screen. And if you need to make multiple measurements, you can now click on the next button. So this is what the calipers help us to do. And for example, this is what I was explaining. Sorry, okay. So I want to measure the femur length. I freeze my image. I select caliper, and here I select caliper. The cursor, this cursor will come up. I will now set. If I set it, it will now lock it. It will lock it there. Then I will now click on next and use my trackball and move this caliper to the other end. When I've reached the end of it, I click on set. So that locks it, and automatically the femur length will now be generated. And I'll get my femur length. This is a linear measurement. So I'll get it in, then I can now, so now the machine will now generate the gestational age and other parameters for me. And the same thing, if you want to measure, you want to use the ellipsoid caliper, when you want to measure an area, like the head circumference, the abdominal circumference, you click on that caliper, and you'll see a cycle will show. You click on the area of interest. Okay, for example, now let's use this one. Okay, this is abdominal circumference. So we want to click on, want to measure the area of the abdomen. So I'll click on set, I'll click on caliper, and a caliper will show. And I will now move it to the other end, okay, using my cursor. But then you set first, then it will lock it. Then you now move it to the, you now move the caliper to the other end. You see this dotted line showing. So depending on the machine, you will now click again on next. On another set of cursor will show, and you will now measure. You take it round the area of interest, the abdomen or the head circumference, depending when if you are taking head circumference. So in that way, you're able to now measure the area or the area of interest, and you're now able to get your AC or your head circumference HC. So this caliper helps us to measure distances and areas. Another common, another mode, or sorry, another knob we see on the machine is the mode. Okay, you see B mode, you see M mode. That is what we commonly use. Now, B mode is for brightness, M mode is for motion. When you are scanning, you're already on B mode. That is the brightness mode. That is the mode we use for scanning. And if you want to now measure motion, you want to measure like in the fetal heart rate, then you now click on M, the M mode. So all those knobs are there on the machine. So you see B, you see M, you click on it. But when you are scanning normally, the one you are using commonly is the B mode. When we are, some machines have it as 2D. But that is the brightness mode. That is the mode we use when we are scanning, the M mode. You only use the M mode when you want to take fetal heart rate or take structures, moving structures. Body markers, well, this helps to, especially when you have to save images, you can use this to show the area of interest. So this knobs provide like a drawing of the specific area that you are examining. So if you are doing obstetrics, you can click on a marker for fetus. I'm clicking on, if you are scanning the breast, you can click on the marker for breast. All this just helps to give a visual representation of our image. So it helps to label the images, especially when you need to save them for documentation or later, or archive them. Display screen, the display screen, this knob helps to display the screen or split the screen into the number of spaces that we want or views. So it allows the screen to be split so you can look at it in two views, like dual view. Normally, when you are scanning, you are in a single screen. Well, you can dual it by clicking. They say knob, you click, and you can now split the screen into two. And this is very important, especially when you want to do some comparison. especially when you want to compare anatomy, that is the normal anatomy and the abnormal anatomy. So you can click on that. But by convention, we are usually on the single plane. So you can have dual plane, you can have double plane. You'll find that the double plane, you will find it very useful, especially when you want to do amniotic fluid index, so that you can now divide the abdomen into 4 quadrants, and you can now use each of, you can move from one, you can now measure the amniotic fluid in each of the quadrants. So this display screen helps you to do that.
Please, can you start wrapping up now so we can take the next lecture?
Okay, so the trackball is another very common. You will always use the trackball. It helps you to control the movement of the cursor, the calipers, the sine loop. You just see it's like just like a ball. You just keep moving it. It's very helpful. It helps you to control all those movements. So most machines also have Doppler facilities. So you see the knob. If you are doing Doppler, then you click on Doppler, power Doppler. That helps to detect flow, just the flow only, not direction of flow. I don't know whether we're going to do all that for now, but just know that some machines have these facilities. Most new machines have all these facilities for Doppler. Clean, clear, back, save. These are other common knobs. These are other knobs that you find yourself using. You finish, you measure something and you're not too happy about it. You can actually clear or clean. And you always use the save button knob to save your images. And you can always, even after measurement, there's a knob called back knob. When you're not happy or comfortable with what you have measured, you can actually click on it and to take you back to start all over again. So these knobs we have reviewed just represent the basics that we are required to carry an ultrasound machine and to carry an ultrasound examination. There are other functions and parameters that can be applied, especially when we are using a modern ultrasound machine. But the whole aim of the knobs or the study of knobology is to ensure that we have our image is of high quality and that we understand the knobs and use them to able to achieve optimization of our image. Because the whole aim of scanning is to have a well-optimized image. If your image is not well optimized, then you will not be able to make some diagnosis, you miss some details. So image optimization is the goal, it's our desired goal as you practice ultrasonography. And this can be achieved by knowing your knobs and applying them and making use of them very well. So other ways of achieving image optimization that you will learn in this program is in the subsequent lectures, you will know that how to acquire your accepted right planes, how you master your probe movement, and how to place caliper placement. All this I know we will learn in this program. I don't want to, I think my time is almost up, but I think yesterday's lecture, we talked about transducers. And as you scan, definitely you will have to select the probe you want to use, depending on the examination. If you want to do an obstetric scan, you need to pick a low frequency, use the low frequency probe or transducer or the curvilinear probe like this. This is what we use for scanning deep-seated structures. Obstetric scan, pelvic scan, this is what we use. This is high frequency probe, most times is for superficial structures. And this is the transvaginal probe for endocavitary scans, the high frequency probe. So these are all the different probe types that we will find ourselves using as we go into ultrasonography. Again, it's very important to select the probe, the transducer, the frequency. Yes, most of them are in a range. For example, that low frequency probe is in a range of 3.5 to 5 megahertz. And depending on the BMI of the patient, you can actually select the frequency that you will use. So when you are scanning a patient, you can go to that knob and select the patient. You have a patient who is very slim. you are okay. You cannot use a frequency of like 5 megahertz. But if you have a patient that is obese, you can reduce the frequency to like as low as 3.5 or 2.5. So you can use, don't always use this your transducer selection knob to adjust the probe frequency as you, depending on the habitus of your patient. Well, the transducer indicator is another important aspect that we have to understand. On every transducer, there is a marker, an indicator orientation mark on the side. So depending on the machine, it can just be a notch, or it can be a color mark, or it can be a bright light. So when you see your probe, just have a look at it. Now, this indicator or this transducer indicator helps you to align the image on the screen with, will help you to align your image on the screen. So when you put, it helps you to know how to hold your probe, the direction. So normally there's a convention that the marker, when you are on the longitudinal plane, it should face the patient's head, while on the transverse plane, it should be to the patient's right. So that transducer marker will help you to make sure that you hold your probe properly in the right orientation, in the right order. So this is what we are calling the transducer marker or indicator. So depending on the machine, it depends on it may just be a notch, it may be a light, it may be a depression. So holding your probe correctly is very, very very important. I think in subsequent lectures, we will have more of that. Okay. So having a probe orientation is one of the things that we are going to learn on as we scan. Finally, I think I want to just talk about the care of the probe. That is, the probe is the most important component of the ultrasound unit. It's very important, it's very expensive, and we should clean it after every use. We should not autoclave, and you should always dock it, like put it in the probe hanger anytime we are done with scanning the patient. So thank you very much. Before I end, I want to say that ultrasound is very interesting. The advantages include that it's safe, it's not invasive, easily available, accessible, and affordable. However, the greatest problem, one of the disadvantages is the fact that it's highly operator dependent and machine dependent. But I'm sure that at the end of this program or this training, we'll find out that we will to see the benefits of ultrasonography and use it for the best of our patients. Finally, I want to say that you will know the knobs of your machine as much as you can. Thank you very much.
Thank you very much, Ma. We're grateful for that awesome lecture. Thank you so very much. So I think we'll just go to the next lecture.